Welcome to my online chemistry class. The first question we're going to look at is a Born-Haber exam question, and we're looking at June 2021. And what we have to do in this case is complete figure 1 by writing the formula, including state symbols of the species, and we're looking specifically at calcium chloride. We need to look at the periodic table so that we can visualize the atoms. So we find calcium, we can see that the number of electrons on the outer shell is not 1, it's 2. And then we're going to look for chlorine, and again we see that the number of electrons on the outer shell is 7. And that gives us calcium chloride, and that is 1 metal for 2 halogens. So 1 atom from group 2, which are the metals, and always pairs up with 2 atoms from group 7, the halogens. And you might be asked a mix and match of those. So you might be asked calcium chloride, you might be asked for magnesium chloride, etc. So with these Born-Haber diagrams, always imagine that at the bottom of the diagram you have a solid and it's a colder temperature, and as you rise you're increasing the temperature and the molecules are getting more and more destroyed and separated up until you're seeing gas. And that way you have a rough idea that as you're going up, the molecules, the electrons are parting, and as you're coming back down, they're all coming back together. So I've broken down the process into steps. So step 1, so working from the bottom, step 1 from the bottom, which is the formation, but we're actually in the reverse of that. The first step is we're going to split up the calcium from the chlorine, so the metal from the halogen. So it is actually the halogen that turns to a gas first. So naturally halogens are actually gases. There's horrible chlorine gas that was used in World War II. And when the chlorine gas is in its gaseous form, it always is as a 2. It is paired together because both chlorines have 7 electrons. So as soon as they're broken apart, they want to come together. As soon as they're on their own, they want to come together so that they both have 8 electrons on the outer rings, because atoms always want 8 electrons on the outer ring, so they share so that they both have 8. The enthalpy change of calcium is then turning the calcium solid into calcium gas. Next is the enthalpy change of the halogen gas, in this case the 2 chlorines. It's 2 times because there are 2 chlorines that are bound together, and we are now separating them into 2 separate atoms. Now is the enthalpy change of the first ionization energy, and ionization energy is just a fancy way to say removing the first electron. So first ionization energy, first removal of electron from the metal. So when we remove an electron, we're then left with a plus charge. We then remove the metal's second electron, and so the calcium is left with a 2 plus charge, and this is called the second ionization energy, the enthalpy change of the second ionization energy. So what we're left with is calcium 2 plus with 2 electrons. As you can see, those 2 electrons have come off the calcium, and then 2 chlorines. So all of this is in the gaseous state, because remember at the very top everything is gas. And then coming back down, it is the enthalpy change of the electron affinity of chlorine. So the the affinity that the chlorine has towards the electron, so its ability to draw the electron to itself. And as we're going back down, so we're coming back together, the chlorine is then taking in the electron, and that's giving us a minus charge on the chlorine. And so that is how we would get to the final answer in the mark scheme.